Greetings and salutations. People have been saying, hey, do some more videos where you show us things about working in a terminal. I say, cool. In this video, I'm going to show you your shell environment. We'll talk about how you can create aliases and functions and scripts to make it more your own. Obviously, this video is going to be for more advanced viewers. You probably already work a little bit in the terminal or the command line or the shell, whatever you want to call it, it all works. Even if you don't, stick around, watch the video. This will introduce you to some pretty cool concepts. And even if you might have to work your way up to a place where you're going to use them, it's nice to have them floating around in your noggin anyway. So, where are we going to start out? Well, I'm going to start out with a very quick little explanation for any of you who are not already familiar with how the terminal works in Linux. When you open up your terminal application or you log into that virtual terminal that you get by using alternate control and one of the F keys, you are actually logging into a shell environment. The shell is the program that allows you to type humanly readable commands into a keyboard and then goes off and makes the system do something useful with it. The shell is one step above the kernel, so it essentially tells the kernel what to do. In most Linux distributions, the default shell that is shipped is bash, the born-again shell. And it has become a universal language for all kinds of computers because you can run bash in Linux, Unix, you can have it on a Mac, you can have it on Windows. You can use bash to communicate with every kind of computer, from a little embedded device, like a little IoT device, or a supercomputer, and it's all the same language. And that's one of the reasons that it is very cool. So if you're going to be spending a lot of time in this shell, it helps to understand the environment and what that is all about. Most people who sit down in front of a Linux computer for the first time, this is what they see, is this prompt that you have in the upper left-hand side of your screen here, and that's it. And this scares people because of the fact that this basically puts it all on you. You have to know what to type next to get this machine to do anything. And it also assumes that you know what you're doing. In other words, it doesn't necessarily warn you if you're about to do something stupid. So keep that in mind as the video rolls along. I might do something stupid and it's not going to warn me. It's going to mean that you are going to have to kind of know where you're going. Well, once you get going and you start knowing where you're going, then you can come up with these ideas in your head about, boy, it would be nice if I would type in this command one way, but it would actually do something else. We'll get into that in just a few minutes. The first thing we want to talk about is your environment. When you log in, the first thing that you see is just this prompt, but there's actually a lot going on behind it. There's a lot of settings and there's a lot of tools that you can use to get things done. So the first thing we're going to do is take a look at our environment, and there's a couple of ways that you can do that. The first way is to use the set command without any arguments, and this will just print out your entire environment. So we're going to take a look at that. Now what I'm going to do is I'm going to pipe this, which means I'm going to send the output of the set command into the less command, and less is a pager that will just allow me to scroll through all the crap on the screen because there's a lot to look at here. So the first thing that we see is a whole bunch of variables. And a variable is just a way that you can stick some little bit of information in memory in the computer and call it back later. That's all a variable is. So you see here we've got a bunch of information here, looking for something that would be semi-useful. So right here is the home variable. And essentially that tells the system where your home directory is. And in my case, it is home Joe right there. And then here's the host name right after that. And the host name is Big Boy. And we can scroll down through here and see that there's all kinds of information about the system, and some of it is gobbledygook. Like here, see where it says ls_colors? What is all that? Well, actually, we're going to look at that a little bit later on. It's just some information that is stored in your shell environment. Here's your operating system right there. So you get the idea. So if we keep scrolling down through here, you'll see all of these different variables that are set. And then we kind of go through that section. And then we see a lot of code, and it's a lot of if statements in here, and different kinds of commands to basically tell the system what to do in a certain situation. It's all right there. So all of this is set up in the background, and it constitutes your environment. A good deal of it you don't even need to mess with, worry about, whatever. It's set up for you, and you don't have to worry about it. But some of it you can change, and you can make it do things for you. So let's go ahead and get out of that. And there's another way to show the environment, and this is actually, it's just a shorter way, it's a dirtier way, but you might find it useful, so I'm going to show it to you, is the print environment command. And if it would help if I got it right, okay, PRINTENV. And once again, we'll put it into less, although we really don't need to. This essentially outputs the variables. And the only thing about it is that it doesn't do it in any kind of order. It's just how they're set. So that's somewhat useful, but figured I would show you anyway. Just in case you can't remember set, you could always remember print environment, and that'll give you the down and dirty stuff. So when we're talking about working with our environment, really we're talking about working with two files. This usually contains the stuff that you will want to change. So if I do ls on my home directory, and then I tell it I want to see everything, that's what the -a does. It means all, show me the hidden stuff too. Then you will see that we have a bunch of files in here that are obviously configuration files. Like here we have a directory called .config right there, and that's where a bunch of configuration files are. The ones that we are really interested in here are .bashrc, and there is another file in here called .profile. That's a really important file. And we might be somewhat interested in .bash history. We also have .bash logout here. We're not worried about that, but that's actually part of your environment. So let us take a look at the profile first. And I am going to use Nano to look at that. So up at the top here, there is an explanation of what this command is. This is essentially the first file that is loaded when you log in. The profile is the first thing that gets loaded. And there's really not much in a modern profile. We don't really edit this very much. This is set up by the system. Of course, you can edit it if you want to. But really, when you're going to be making changes to your environment, you're going to be doing it in bashrc. So right here is where it looks for the bashrc file. It's pretty much the first command. First it checks on the bash version, make sure that you're running bash right there. And if it does, then it says, oh, we can go ahead and load the bashrc. So this is the command to do it. So if that file exists, bashrc right there, then we will load the local bashrc right there. The dot right here is the read command. This just tells the system to actually read that file. And then we use a shell variable to kind of make it easier on the script writer here. He doesn't have to know that your name is Joe or Sam or Bob or Kinsey or whatever your username is. It makes no difference because this is the variable that's set when you log into your environment for your name. Well, actually, no, it's not your name. It's your home directory right there. See that? There you go. You figured. You knew what I was talking about. So then that loads this bashrc file. Then it does one more thing before it ends up stopping what it's doing. It will load the bin directories, your local bin directories here. So it's doing it right here. Now, for those of you who are not already familiar with writing your own scripts and programs, what that basically means is that any program that you write yourself or compile, you can put in this local bin directory, and you have complete control over it. It is yours, and it runs in your environment. So you would create a directory in your home directory called bin, and if it finds it, then it will throw it in there. Another place that you can put your own personal programs like that is in .local/bin, which I guess is sort of a kind of a neater way to do it if you don't want your bin directory showing up in your home directory. But it's, for me, I just put it in bin. I like being able to get to the stuff, and we'll actually talk more about that later on in the video. So that's what the profile file does. That's it. So let us go and take a look now at the bashrc file. This is a much more involved file. So we'll use nano once again. So this file actually goes on. There are more commands here. There's more to look at. So right up here, something that you might find interesting is a command to set a variable in the environment that tells the part of the shell that keeps track of your history how many commands to do. It'll do 1,000 lines. It sets an absolute size to the history file right there. You can change that if you want to, if that's important to you. Also in here, it talks a lot about different prompts under different situations. And here is where it sets your main prompt and whether you want that prompt to be in color or not. And so for interest, okay, let's go ahead and if we have this set here to yes, then it would do this. Now, Ubuntu now sets that somewhere else. It used to be that you'd had to go into your bashrc and uncomment that line, or you would not get a color prompt, but Ubuntu sets that somewhere else, and I'll show you where that somewhere is in just a few moments. So that variable is already set elsewhere before this file gets loaded, and then it goes through and does that, and it has to load up all the different colors. One of the things that you can do with your bashrc file is to modify your prompt to get it to do different things, and it's very flexible, so it can show you all kinds of information or not show you information. As a matter of fact, up until I was prepping to do this video, I was running a custom bashrc file that changed how the prompt worked, and I got to looking at that and I went, I don't think I really want that modification anymore, so I went back to a standard bashrc, which makes it better to do the video anyway, because if you sit down in front of Ubuntu 18.04, you'll get one that looks an awful lot like this. Of course, what's in your bashrc file is going to depend a great deal on what distribution of Linux you're running. Linux Mint used to ship without a local bashrc file at all to the user and use the master. I'll show you what that's about in a few minutes. So as you can see here, gang, there's all kinds of situations where it's looking to see if things exist, and if they do, this is what we're going to do, and we'll set it up this way. Now, this is the next thing we want to talk about here is aliases. So we have aliases that are set up on this system, and we'll use the aliases for the ls command as examples here. So the first one that you see is that if we type in ll, we're going to get ls with certain options. I'm going to show you how to take advantage of that in just a few moments, and we'll get down into that because that's really the meat of what we're talking about. So if we get down here, there is a place where you'll see that we can create a file called .bash_aliases. And your bashrc file will go look at it. So if you have a whole bunch of aliases that you set up for whatever reason, you can put them here in this file, and it will find that, and it'll just load them. And then the only thing you have to do is manage the file, and you don't have to come and edit on the bashrc file if you don't want to. So now we've basically made it down to the bottom of the file, and this is all the standard stuff that comes with it. So we're going to talk a bit about putting that to use. But before we get into that, let's talk about where this file comes from, because this is kind of an important thing to know. So the system has a universal file that works for all of the users, and that is in the etc directory. So let us do ls etc, not ertc, just tc bash, and we'll tell it that we want to see everything in there with bash, and it's got anything after that. So you see now that we have a file in here, right there, called bash.bashrc. That is the master bashrc file. And actually, a lot of the settings that we looked at in our local bashrc file might be in there as well. They might have some different settings. Like, I'm sure that's where Ubuntu has it set up to give us a color prompt. That's happening in that file right there. So that actually runs before the local profile does, and we don't need to mess with that. The only time that you would want to mess with that is that if you are administering a system and you want to make a global change that's going to affect every user. So let's say that you create an alias and now you want everybody to have access to that. Well, you put it in that file. And by the way, you can have the same commands more than once. So you could have a command that would be in the main bashrc file, it would be in your profile, and then it would be in your local bashrc file. Doesn't matter. The system will just put it back. It doesn't care. It's just redundant. It goes, oh, we're doing that again? Okay, boom, it's done. You can do it more than once and not worry about breaking something. So anyhow, okay. So when your user account is created on the system, where does it get a bashrc file to put in your local directory? Good question. So this time around, we're going to run ls, and we're going to use a once again to show everything, and we're going to look in etc, and we're going to look in a directory called skel, and I'm just going to show everything that's in that directory. And look, there is a .bashrc file, which is going to look just exactly like the one we just looked at, because I'm now using a default bashrc file, and I don't have any aliases or modifications in there. So this is a good thing to know if you ever get into a situation where you're messing around with this kind of stuff and you end up messing up your bashrc file. If you want a fresh one, you want one to start over, like this is the default one that was sent with the system, that's where you can find it. And before you start messing around in your bashrc file or your profile, whatever, you're going to want to make a copy of it. So let's go ahead and do that right now, because we will be editing on this file a little bit later on. So we're going to copy bashrc and we're going to put it into a file called .bashrc.old. Or you could make that back if you want to. Either way, it's the same concept. This is always a good idea to do this before you start messing around with stuff. And we're going to do that because we plan on messing around with this stuff. Okay. So, let's talk about aliases. There are two kinds of aliases. The first alias is one where you will type in a command and the system will actually do something slightly different, but it'll have the same name as a command that you always use. So let's go ahead and clear the screen. And the alias command works like this. We do alias and then space, and then the name of our alias is going to be, in this case, nano. And it equals, put this in single quotes, and the command you want the system to actually run. So in this case, I have just aliased the nano command, which opens up the nano text editor, and now it's going to open up nano with that L option right there. And we got no output, so we know it took. So let's find out what that L option does to nano. Makes it create line numbers. So if you want line numbers in your nano text editor, that would be how you do it. So there's a lot of programs like that that you would probably want to open with some sort of options. And LS is one of them. And we saw that there were aliases already set up for LS. So when we type in ls, it's actually got the option turned on to show us colors. See how we have colors in our directory, and different file types have different colors assigned to them. And that is what we were looking at in our environment, or in the first part of the video anyway. To go around an alias, you can bypass it by simply putting a slash in front of it, like so. Now we get ls without any colors. Pretty cool, huh? We can do the same thing with nano. Even though I set that alias, we're going to ignore it. So that's nice. I set an alias, but you notice that it's not permanent. The next time I log in, it'll go away. It might be useful to set a temporary alias every now and again. So how do we create an alias? Well, now we get into some real fun. Because there's several ways to do this. I mean, it's one of the beautiful things about working in Linux. There's always more than one way to skin a cat. And for people all around the world, I know the thought of skinning a cat is, whatever. But that's an expression where I come from that means there's more than one way to do something. So before we get into showing the aliases and how you make them permanent, let's talk about the other kind of alias, which is one that is actually where you have kind of a different custom command that might go off and do something else. And we can still use ls for our example. So you might remember that we had an alias set up that was ll, right? And ll is ls with a whole bunch of different options that give us a long listing and show us all kinds of crazy information. So that is ll right there. Now, when we start getting into aliases like that, they start becoming pretty close to being like scripts. And that's how I handle it. But first, let me show you the traditional way of setting up your own alias and making it stick permanently. So what we're going to do is use our nano program again. And we're going to get into our bashrc file, like so. And we're going to go all the way down to the end of the file. We don't want to mess with any of this stuff in here. We have no need to change anything. We like the way our prompt is, that sort of stuff. And we'll add a line down here. And this is just like working in a script. You guys might have seen videos where I've done that, because it's sort of a script. It's just a bunch of commands. And we want to put a comment in here. Anytime that you make a change to a file, you want to explain what you're doing. So put in alias. So that's what that does. And now we can put our alias command in. Did I spell that correctly? I didn't feel that. Okay, yeah, that's right. Equals. So now our alias command is in there. And all we have to do is to save our script, or actually our bashrc file. Yes. And out we go. Close that. And I guess maybe what we can do is to reload our bashrc and make sure it takes. So how do we do that? Well, remember early on I showed you that little read command? So that's just a dot. All it does is tell the shell, would you reread this file, please, and put what you read in memory. Thank you very much. So we'll put .bashrc, and it reread it. So to see whether nano is going to do what we need it to, go, well, our alias obviously took. So now, every time we log into our own environment, we're going to be able to use nano and have that alias on it. Now, you're not a real geek if the light is not dawning in your brain right now at all of the weird and wild and strange things that you can do with your bashrc file. And you just be my guest. But we're not done yet. That's just the first thing I wanted to show you. So another way that you can add functionality to your bashrc file is to create functions within the bashrc file. And a function might be a whole bunch of different commands. So let's give that a shot. Let's see what happens when we do that. So once again, let's jump into our bashrc file, and we're going to use Nano. Nano is a cool text editor, and it does all kinds of really cool stuff here on the command line. And no, I don't like VI or VI. Ugh. Have fun in the comments with that. So now we're going to go all the way down to the end of our file here. And we're going to place in here a function. So a function is just a bunch of commands that you want to load into memory. This is used in programming all the time. And one of the nifty things about working in the shell, it's not just something that opens up other programs. There's a programming language that goes along with it. And we can take advantage of that. So we're going to do a function to show system status. And what should we call our function? I'll tell you what. Let's make it real easy. We'll call it system and dash system status. And there are two formats for doing functions. This is the one that I can remember because I do this in programming all the time. So we put those two little parentheses looking at each other right there, and then we are going to add that little bracket. And then down here is where we put our commands. So I'm going to cheat. What you going to do? I'm going to go open up another program, and I'm going to steal the commands out of that and stick it in our function, because it's going to be a lot easier to do it that way. So here we go. Let's use less, and then we are going to look in bin, because this already exists, and we're going to call it checksys, and that's going to show me all my stuff. Now I'm just going to steal all this crap right here. But I do not want, see this exit command down here? We don't want that. Wouldn't be a good idea to put it in there. And I'll explain why as we go roll along here. We go, and we're going to copy that. Copy. And we're going to place, no, that's not what I wanted to do. Thank you very much. We're not done with the video yet. Don't show that slide. Hit the wrong keys. So we paste that in there like that. And now when we get done putting the commands that we want to have loaded in memory, we can just use that other bracket like that. Enter, and we're done. Now, what this will do is every time that our environment loads, this group of commands will load, and it will become like a program. It will become a command of its own. Like an alias, this will replace a command elsewhere. So let's say that for some reason, and this is purely hypothetical, that you're using Nano, and you want Nano to do all kinds of more than one thing. You want to run a script before you run Nano. You can just put your commands in there, and this will take over from that. Aliases always come first in a script. Now, in your environment, and then it actually goes out and starts looking for the actual command in the path statement. And we're going to talk about that here in a little while too. So, one of the rules of thumb is if you're going to create a function that is going to be in your environment, it will only be for you, but it will block out any commands. So don't use a command that already exists. Now, obviously, there's no program on the system called system status, so we can use that. But make sure that there's not a command somewhere in the system that will conflict and you might lose access to. So let's go ahead and save this. And we'll exit Nano. And we can go ahead and clear the screen. I'm going to have to get rid of that other terminal back there because we don't need it. It's glaring. It's annoying. Go away. I don't care. Close the terminal. All you had to do was hit Q. I don't care. So what were we doing? Oh, I was going to show you. Let's make sure that there is no command called system status. Of course, we're doing this backwards, but I want to show you. No, it doesn't exist. So if the which command doesn't put anything out. Let's read bashrc once again. And now, let's see what happens when we put in system status. Don't think it'll autofill. No, it won't. You're going to have to type the whole thing in. And hopefully I got it correct the first time around. And it's saying command not found. Must have typed it in wrong when I did my function. Hold on, let me go troubleshoot. Be right back. I had that spelling on that thing all jacked up, and you didn't tell me. You knew that was coming, and you were laughing at me, weren't you? You were. I heard you out there. It's okay. It's all right. Happens to the best of us. So I have fixed it. Now I will exit. Now we will reread the thing, and hopefully it'll actually work this time around. Okay, so now we're rereading. What seems to be the problem again? Oh. Forgot the period. All right, so now let's see if this works. System status. You got it wrong again. Yeah, I did. I'm all flustered and making mistakes. You all are mean. All right, it works. So it's running that little bit of information, and it's showing us some stuff here. Pretty cool, huh? Yeah. And of course, every time I hit that, it's going to work. Now, the bad thing is that is only available to you. You do not get the autofill function, which means that every time you want to run that thing, you're going to have to do it like this. You have to type that whole deal in. See, I can't autofill, and it doesn't know it's there, and that's the downside. But it is a possibility, and you can do it, which is why I wanted to show you how to do it in a video. You can do it! So, when I'm dealing with a little thing like, we were talking about the two different kinds of aliases. There's the kind that absolutely replaces an exact command like we did with nano. And then we have these little things where we have our own little names for things, but it might run a command in a slightly different way. Well, you can do that as a script. So let us clear the screen. And this is how I choose to deal with this. This is how I choose to work with this kind of stuff. So let's jump into my bin directory. And we'll do ls, and it will show all kinds of little scripts and little programs that I have come up with. And if you've watched my channel, you might know what some of these are already. But the main one that I want to start out looking at is, let's look at this thing called nr. So this is actually a script. This is a bash script that is running on my system, and it's essentially just an alias. So I could do the same thing with alias and then use the name nr, and that would equal this command right here, which restarts the network manager. So if there's a problem with my network, that restarts, and there you go, right? Right. So this for me is a little bit easier way to keep up with my own stuff, because it all goes into the bin directory, and I can back it all up, and I don't have to go searching through a file to look for things. And this is how I do it. Let me go ahead and get out of here. And this little checksys program that we looked at earlier, well, that's just another script as well. That's all it is. So just a few commands put into a script. So if we wanted to create a script, I'm going to take you through it because it's actually really quite easy to do. So let's say that we want to make a script and we want to put it here, and we'll call it hello. Yes, I'm going to use that example. I'm going to do it. You guys know what's coming, right? Yeah, I'm just showing you the basics of making a script. So we use nano, and then we're going to call our script hello. So I'm going to go ahead and give it a file name to start with. That way we don't have to do that later. And the first thing that you want to do in a script is you will want to put in the hash bang or shebang. And it looks like this. And we'll write this for bash. Now, you may have noticed in the script that I showed you before that it didn't say bash here. It said sh. And you might be wondering, what's that all about? Well, sh is the shell. And a lot of old books that you'll read about scripting, they'll tell you that if you want to make a program run on every Linux system anywhere, that you should write your code for sh. It's a slightly different language than what we have in modern bash, but it's actually pretty close. And the reason why you do that is just simply because you know that script will run anywhere. Not every Linux system that you could sit down in front of would be running bash. There are other shells, but every Linux system has sh. So when I wrote that script, that's why I did that. So that's going to tell the system, hey, we're writing for bash, so would you please run this in bash? Okay, so, well, let's just put in one command. It'll make it so much easier. We'll do echo, and then we'll put some text in here. And the text will be, yeah, you got it. Gee. And then when I'm done with my scripts, I always like to put exit in there. So we're going to write that out. Control X. And there we go. So we are now have our script. We can make sure it's here. You see that we now have a file in there called hello. So let's run it, right? Well, it says no, you can't run that. What do we forget? Well, what we forgot to do was we forgot to tell the system that it's an executable. So this gets into file permissions. And I'm going to show you a really quick and dirty way to make your scripts executable. No, you don't have to open up the point and click graphic user interface based file manager and then right click on properties. No, you don't have to do that. You don't have to do that at all. No, what you can do is just do it at the command line. So let me show you a little bit about permissions, because I have mentioned this in videos in the past, and when I have done this in the past, some folks out there have gotten confused, and I want to show you what this looks like. Well, that's not going to work, because I tell you, man, you're doing a video, you're going to slip up, you're going to add extra keys and do all kinds of crazy stuff. Okay, so let's look at this file real quick, because this is going to talk a bit about permissions. So remember when we looked at that long list earlier and we saw that we had that gobbledygook over here? This is the permissions that are set for each file. It's one of the reasons that Linux is very secure, because we have, first of all, a little bit or a byte of data that is set that tells us that what kind of file this is. So if it's just a dash, it means it's a regular file. D means it's a directory. L means it's a link. If we get into the next set of 9 characters there, you'll see that we have first one, a set of 3 that represents the user. This represents the group that the file belongs to. And this represents anybody that has access to the file for whatever reason. And we can use this to our advantage to keep people from reading our files and all that kind of stuff. Today we're really worried about making them executable. So you'll notice here that we have octal. And this is where you can set the permissions just by using numbers. And all you got to do is remember that if you want to make a file readable, then that equals 4. If you want to write a file, that equals 2. If you want to execute a file, that equals 7. If you want everybody to be able to do that all at once, then the number that you remember is 7. So I put this down here because in past videos we've talked about this and it gets people confused. We have 8 bits in a byte, and this represents like 1 byte worth of data. And we do 0 through 7. To set our permissions, we only worry about 1 through 7. That's it. 0, yes, that is a bit. So when we say 8 bits in a byte, we have 0 through 7. But we're only worried about the numbers 1 through 7 in this particular thing. That has confused the hell out of a lot of people, and I hope I made it clearer this time around. So now can we go ahead and get out of that? Yeah, let's go back and get back to what we were doing. So what we want to do is we want to make our script executable. So remember, 7 means that anybody can read, write, or execute the file. And 4 means read, and plus 1 more would mean that somebody in a group could read and execute, and the world can read and execute. Name of the file. Hello. Well, it took it, so it must have did it. Let's see. What happens when we run hello? Why, it just says hello world. There you go. So, that is how you can use scripts to execute one command or 2 little commands. And what we're going to do now is, the last thing we're going to look at is getting your bashrc file to execute commands when you launch the system. So let's get back to our bashrc file. Get back to our home directory to look at it. So I hear a lot of you out there and you're saying to yourself, you know, that setting up a function thing at the end of the file, man, you know, that's kind of a big pain. I really don't need to do that, but I might want it to actually just run something. So we're going to go ahead and remove our function because you don't want to do it that way. That's fine, but you never know. You might run into a reason why you might want to do that way later on, man. You might want to. So let us put a command in here that will just simply run a script that has exactly the same stuff in it. Remember I showed you that little checksys script? So we can just put our note here. Right there. And what you're going to want to do, if you're going to run a file, you're going to run a program out of your bashrc, you want to kind of make sure that you put it in such a way that the machine won't have to look for it. We don't want to have it go to the path to look for it. Now, I mentioned this earlier. Now is when we get to follow up on it. So what we got to do is we got to tell this thing exactly where this program is that we're running. This is good practice for every script, and it's actually a practice that I break a lot. I don't do this, and you should. What you should do is give an exact path to any program you want to run. So I'm going to tell it to look in Home, Joe, and we're going to look in the local bin folder, right? And then we are going to look for that program, checksys. Right there. So we can go ahead and save our file. Control X. And we're out. Once again, let's read bashrc. Now this time when it reads bashrc, it should execute that program. We'll know that it's working. Yep, it did. So what am I talking about path? This is very important to understand. So you remember that when we were looking at profile, that is where it put the path statement for our local bin in there. But it loads bashrc first. So if I would have just put at the end of this file here, come on, if I would have just put at the end of this file to load this command checksys, it wouldn't work because it doesn't know it's there yet. It doesn't have a clue. Don't make that mistake. If something doesn't work, it's like the first thing to check for. So right now, our path, this is another thing about path I wanted to show you before we got out of here, was, let me see, I want to show the path. I'm getting it to show us the variable. This is all the places that it will look. And you will notice that the very first place that it's going to look is in our local bin directory. So it's /home/Joe/bin right there. That means that we could use the first kind of alias that we talked about and put that in a little script if we wanted to. That's not accepted practice because if you ever run that in a situation, if you're not in your own environment, you're not going to get that alias. Of course, that's going to be true with your bashrc as well. So we don't even have to modify our bashrc file. We don't have to add any aliases if we don't want to. We just need to come up with a little tiny script to do that if we wanted to. And that's how I handle it. That's exactly how I do it. So once again, go back to bin. We'll show you one more example of that, and then I will wrap up the video. and we are going to list the storage. And I think the one that I want to show you is SSHN. Now, SSH is the secure shell. This is how you log into other computers. And here's what SSH does. So let's just show SSHN. And you'll see that it's just a little bit of text here. Now, what this does is it uses a shell variable so that I don't have to type in my entire network address if I want to go into another machine. So you'll see down here where it says the X, that also makes it so I can use something called X forwarding, so I can run graphic applications with another computer. So let me show you how it works real quick. Go ahead and get out of there. Okay, so on most networks, or if you're dealing with a server that's on the internet, you can just get into it by putting in the name of the machine. So I can do that on my local machine here. The name of this machine is Big Boy. And it will log me in. I'm now logged into my local machine, and yes, it remembered to run the system status there. So that's great. That's not a problem. The only problem is I can't do that on my network with other machines. Get out of there because I don't have a name server running on my router, and a lot of modern routers don't, which means that it can't resolve host names. And so the only way to do that is to do it through using a network address. So that would involve me having to type in every time that I wanted to get into this other machine, SSHX, and then the whole dang address for this other machine. And I'm logged in. Well, that's going to get to be a drag. So that is why I created that little thing. It takes the variable in there was $sign and then the number 1. Well, what that is the first argument after any command. And it's stored there in the shell. Remember we looked at all those different variables? So we can call that again later in a script, and we can put it in there. So now all I have to do exactly the same thing is type in SSHN, and then I can type in 13, because that's what the machine that we got into before, and I'm in, and everything's the way it is. So that is, you could do that as an alias, you could do that as a function, or you could do that as a little tiny script in your local bin folder, which is how I choose to manage this sort of thing. I have armed you with a great deal of information in this video, and I hope that you go out and make use of it and do interesting fun things with your .bashrc file, or you start writing little scripts to get things done. Whatever. This is one of the really cool things about working with Bash and working with a terminal, is that all of this stuff is sort of universal. Doesn't matter what machine you're sitting down in front of. And you can take your little aliases file or your little programs and put them on any machine that you're running in your own local environment. It doesn't affect the big system, and you can have your own little world. So there you go. You have been introduced to the environment. Your feedback is always welcome. Please join the discussion at Easy Talk. Also, that is free, secure, and fun. I wrote that, so I would remember to say that. And it's our forum. You can check out Easy Linux on Facebook. Give it a like if you are a Facebook user. Also, check out easylinux.com. That's where all of that comes together. And it's where you can contact me directly through the contact page. And check out freedompenguin.com for more stuff about Linux. This video just may end up at freedompenguin.com, along with a lot of other content from a lot of other cool people. Yeah, that's it. This was fun. Thanks for hanging out with me. We'll do it again soon.